Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahri bin Suhaimi. I'm from J4 EM1104A and I'm from group N4, and today I'll do an experiment of F1, which is hydrostatic force on plane surface. Let's go for the objective. We have two objectives. The first one is to determine experimentally the magnitude of the force of pressure, which is hydrostatic force, and its point of action, center of pressure on both submerged partially submerged plane surface. And for the second one is to compare and analyze the experimental result with the theoretical values. Okay, next we will go to the apparatus. Okay, for the apparatus, we have 11 apparatus that we need for this experiment. The first one is counterweight, number 2 is tank, number 3 is the drain valve, number 4 adjustable feet, number 5 balance arm, number 6 quadrant, number 7 balance pointer, number 8 balance pen, number 9 weight, number 10 depth of immersion scale, and lastly 11, which is the spirit level. Okay, for the procedure, first we need to place the hydrostatic pressure apparatus on the bench, and next we need to make sure that the apparatus is installed properly. This is to prevent any errors during the experiment when this was doing. And next, okay, for the third procedure, we need to level the apparatus using the adjustable feet facilitated by the spirit level attached. This is to make sure that the water level is on a stable and doesn't disturb with the experimental or will make any errors during the experiment. Okay, number 4, we need to adjust the counterweight to level the balance arm to horizontal position. And then number 5, we need to make sure that the drain valve, which is the V6, is closed, and this is to prevent the water from leak from the tank. And then we need to slowly add water into the tank until the surface just touch the quadrant base, thus establishing the data level corresponding to the zero at level scale. Okay, number 6, we need to place a 50 gram weight on the balance pen and slowly add water into the tank until the balance arm is again horizontal. Okay, number 7, after we done the procedure 1 until 6, we need to record the mass of the weight, which is the M, the depth of immersion D, in the experimental data sheet. And then after we done with the record the data, we need to repeat the steps 6 and 7 with increasing the number of weight until the tank is full of water. After we done with the with all weight, we need to drain off the water after the experiment is complete. For draining the water, we need to bring the tank carefully to the nearest sink, and we need to open the valve V6 to take the water out. Okay, for the sample calculation, that we are given the height of quadrant D, which is 0.1 meter. We also get width of quadrant, which is B, with 0.075 meter, and then length of quadrant, which is L, 0.275 meter, and then we get a quadrant of pivot H, which is 0.16 meter. We got density of water, which is 1000 kg over meter cube, and then we get the gravity, which is 9.81 meter per second squared, and lastly we get the mass of load support M, which is 0.04 kg. And for the calculation, we need to find 4, which is the resultant hydrostatic force, which is F. After that, we need a second moment experimental, and the third one, second moment for the theory, and lastly we need to find the errors. Okay, first we will go to the resultant hydrostatic force first. For the formula, we use the F equal to rho G B D squared over 2 for the formula, and then we can put the information that we get, which is rho, which is 1,000, and then for the G, which is 9.81, we will multiply with 0.075 for B, and for the D, we will choose from the data, which is 0.046, and we will make it in squared, and we divide with 2. After we done with the calculation, we will get 0.778 Newton, and Newton is for the force. And then after we done with the force, we go to the second one, which is the second moment for experimental. The formula that we use is H equal to mgl over F. The L here is the length of quadrant, which is 0.275. The M here, choose the first line for in the data, which is 0.05. But when we want to do the calculation, we need to add the mass of float support, which is 0.04 kg, for the calculation. So the calculation will be 0.05 plus 0.04 kg, and then we multiply with the gravity 9.81, and we also multiply with the L, which is 0.275. After that, we need to divide the answer with the 0.778, which is the force before, and then we will get the second moment for the experimental. And then we go to the third one, which is the second moment for theory. The symbol is same, which is H, but the formula that we use is H, the bigger H, we minus with D over 3, and the bigger H, which is the quadrant of pivot, which is 0.16 meter. We will subtract with 0.046, which is the depth of the water, and we divide with the 3, and we will get 0.145 meter. And lastly, for the errors, the formula that we use is theory, we minus with experimental, we divide with theory, and after that we will multiply with 100%. And after I do the calculation, which is 0.145 for the theory, I minus with 0.312 for the experimental, divide with the theory again, which is 0.145. After that, I will multiply with 100%. The final answer that I get for the errors is negative 115.17%. For the application that used in this experiment is the water dam, and the water dam works with the dam is built in such a way that the bottom is thicker because water pressure increase as the depth of water increase. So therefore the bottom part of the dam is thicker to withstand the high pressure, so that the dam doesn't break easily. In conclusion, the magnitude of the force of pressure, which is hydrostatic force, and its point of action, which is the center of pressure, are determined experimentally on both submerged, partially submerged plane surface through calculating the second moment from the result of the theoretical values, in which they differ due to several errors, including instrumental errors and environmental errors that may affect the hydrostatic force. That's all from me. I hope you understand with my explanation, and goodbye.